As mentioned in the introduction, mathematical notation can sometimes make concepts more complex. For example, in the previous problem you described where the graph of the function is increasing. By definition, and this is something I usually like to write down in the notebook if I ever have some sort of bolded lettering or any different colors, I like to write some of this stuff down. So by definition, and then we have this long thing here that I'm not going to read out here, but really the important part here is that it simply means that when you are tracing along the graph from left to right, if your finger is moving up, then the function is increasing. And that's why I like the definitions of this book, because it kind of makes it a simpler description as opposed to all the mathematical speak. So that's kind of what I would write down in my notebook. So A, apply the definition of an increasing function to Riley's drive. In Riley's situation, let x1, or the first x value, be 1.5, and x2, or the second x value, be 2.0. What are the f of x1, or the y value, and the y value at x2? Is this number here, the y value at x1, and the y value at x2, is the y value at x1 less than the y value at x2? And I'm just going to go down here and see if I can paste the graph that we're looking at. There we go. So again, let me just kind of see this on the graph. So if I'm looking at x is at 1.5 right here, x is at 2 here, is the y value here less than the y value here? The answer is yes, because it's lower, and so that we know that it is increasing. If you choose any 2 points, any two x1s and x2s between 1.5 and 2, is f of x1, or the y value at x1, less than the y value at x2. So if we're picking any 2 points, right, if I pick here or here, it's still increasing. If I pick here or here, it's increasing. And so in any of the points, it is always increasing, or it is increasing continuously. For C, it says, if so, then f is increasing from 1.5 to 2. Sketch an example of a function that has an interval where it is increasing. Label 2 points on the x-axis, x1 and x2, such that x1 is less than x2 on your graph. Is it true that, all the math speak, and explain. So what I'm going to do is I'm just going to look over here. I'll do this part in orange to make it a little bit different. But I could see here, like, let's call it like right here. This is 1, 2, 3. So this is like 2.5 hours or whatever. At 2.5 hours and at half of an hour, I chose 2 points here on the graph. And if I'm looking at it, I see that the y value on the first one is less than the y value on the second one. You'll see as we go forward, we're going to use this x1 and x2 idea a lot. So when there's multiple x values, we put a little subscript of 1 or a subscript of 2. So my y values, the x1 y value is less than the x2 y value. Now that you know the definition of increasing, write a similar definition for decreasing function. So math speak-wise, I'm going to rewrite this and say, like, I'm still going to go from left to right. And this part here is the piece that says I'm going from left to right, because I'm picking 2 points, let's say like this point right here in green and this point right here. I'm picking 2 points where x1 is less than x2, meaning I am going from left to right. So that's going to stay the same. Now the thing that's going to change is that f of x1, so the y value at x1, is going to be greater than f of x2, because I'm saying that the y value for the first point is higher than the y value on the second point, because that would give me a line that is going downwards, and that would be decreasing.